Hello, I'm Thomas, the pilot. I'm the pilot flying the Airbus A340 311 in this flight from Zurich International Airport back to Zurich International Airport. And we're gonna be flying on flight level 250, 25,000 feet with Mach 0. Maybe 78 and Mach 340 knots. And right now I'm in the cockpit doing the aircraft preparation right before takeoff. And maybe we're gonna make engine start at display, and I'm going to be explaining you the Airbus A340 300 cockpit and engine systems before takeoff and after landing. So here is the cockpit of the Airbus A340 300, as you can see. Here is the flight controls side stick. We use this side stick to move the ailerons and the spoilers in its wing to make the aircraft bank roll in the air by creating differential pressure between the left and the right wing. It actually is electrically controlled by 3 prims and 2 sex computers, which order weight G-load shift change in flight when it is flying in normal load, because it's a fly-by-wire aircraft. But when it is flown without flight computers, it's flown in direct load, so it can be flown with direct side stick inputs, or in some other conditions like after takeoff and before landing, like 100 feet above ground before landing and 50 feet after takeoff. It's flown in direct load. So I'm going to be showing you some other systems. Here you can see I'm also using this to command the side stick. As you can see, I'm using this which is a Logitech 3D Extreme side stick that resembles the Airbus side stick. So if I move the side stick left, I control the left aileron up and the right aileron down, and so the left spoilers go up too and make the aircraft bank roll to the left, and if I do the opposite, it goes to the right. So if I pitch it up the aircraft, I just pulling the side stick up, and when I want to pitch down, I just push it down. So I'm gonna be showing you some more systems here if I have some time. Here's the primary flight display, you can see with the horizontal situation indicator, as they call it on the Boeings. Here's the flight mode annunciator. Here is the auto thrust. If I arm the auto thrust by pressing the switch on, you can see the thrust idle mode here is engaged, because I have the thrust levers in the idle right now. So if I'm gonna move them all the way up to the takeoff go around of the MCT, you can see the manual toggle here, takeoff go around, or the MCT maximum continuous thrust is and here is the thrust climb, which is because I'm having the thrust levers in the climb tension, but this is used after takeoff. So here we have the airspeed indication and the altitude indication, which is the barometric altitude. Like right now it's 1,400 and maybe 30 feet, and here is the magnetic or true heading of the aircraft. Right now it's 136 maybe degrees. So here is you can see other modes here. If I'm gonna press these buttons in, the airspeed is managed by the flight management computer, and the heading is managed by the flight management computer. So it will be displayed here in the flight mode annunciator. We also have the flight directors displays and the vertical rate of climb or descent in feet per minute. Here we have the navigation display. You can see the magnetic or true heading. I can show you some more airports here. or waypoints. So if I'm gonna press the airports here, I'm gonna have some more airports around the aircraft. I can have terrain on the display, maybe. This is the radar, which I can use for terrain display and for weather radar. Maybe if we move this display something, yeah. Again to the maximum. Maybe it's not displayed in this simulation right now as a weather and terrain radar. But let's talk about the other systems right now. Here is the flaps, which are used to increase the lift of the aircraft. You can see if I move the lever down, the slats and the flaps are also moving down. You can see the flaps are going down here. Here you can see the speed brakes, which are also some of the spoilers, and the aileron, which I'm all using this. So I'm gonna use less for takeoff maybe. But before that, maybe I'm gonna make an engine start demonstration. So I'm gonna pull this up. So here we have some of the systems, the RDIs, which I need for all 4 engines, and the wings RDIs. Here is the engine bleed from each engine and from the APU. We have 4 engines, 2 in each wing. Engine 1, engine 2, engine 3, engine 4, and the APU, which is the auxiliary power unit, which is used for engine starting. And here is the electrical panel. You can see we have 1 IDG generator from each engine. We have 4 engines as I told. They all work right now. We have 2 batteries and 1 APU battery, 3 batteries in total. You can see some, here's the APU generator conductor, which is used for starting the engines in the ground. And here is the fuel panel. I'm gonna be talking about that in a while. It has the fuel tanks. And here is the hydraulics panel. I can show you a better display of that. Here is the ECAM, as they call it in the Airbus, the engine indication and crew alert system display. Here is the engine display. You can see if I'm gonna move the thrust levers all the way up, you can see the engine's indication is rising, because the blue dot over here, the blue circle, is where I have set my thrust levers right now. So if I'm gonna move them down, you can see the blue circle goes all the way down. And here's the N1, which is the low speed rotor front fan rotation speed, which can go up to the maybe 104, I think, for takeoff. And here's the exhaust gas temperature, the N2, which is the high speed compressor, the high pressure compressor rotation speed, which is 63% right now. The fuel flow in liters per hour per engine is 2,000 pounds per hour per engine. The fuel on board, we have 72,000 pounds of fuel. We can see some other indications here. The lower ECAM, you can have additional engine status, the fuel used per engine, 440 pounds per engine, the oil quantity, the oil pounds per square inch, the oil pressure, the oil temperature, the vibration of the engine of the N1, and the vibration of the N2. And the NAC, if I remember, was the air nozzle temperature, but I'm not sure about that. So here is the gross weight, we have to set it up, and gross weight, center of gravity, and the total air temperature and the saturated air temperature. And here is the air bleed that I was telling you from each engine. As you can see, engine 1, engine 2, 3, and engine 4. they all working right now because all engines are working, and the isolation valve is closed right now. Here is no, and here is the APU and RAM. Yeah, here is the packs out, so the left and the right. The APU is not working right now. Maybe I should turn it on because we're gonna make an engine start demonstration. So here, if I'm gonna press these two buttons, we're gonna have the APU running in a couple of minutes and supplying air if we need. Here's the cabin pressure, which is the system that pressurizes the cabin of the aircraft. Here is the electric alternate current, one from each engine, generator 1, generator 2, which is displayed right now, but it's actually both generator 1 and generator 2, and generator 3 and generator 4 for generator 2. And we have the external A and external B, and the APU generator, which is gonna be available in like a couple of minutes maybe. Here is the alternate current essential bus, which supplies the aircraft system. Here we have 115 volts, 400 hertz. Here you can see the APU start supplying the aircraft right now if we need it. So here is the electric direct current, which is from battery 1, battery 2 and APU battery, which supplies only the battery, and the APU transformer rectifier, which is to charge the APU battery from the alternate current source. And here is transformer rectifier 1 and transformer rectifier 2, which transforms the alternating current from the engines of the APU into direct current to charge the battery or supply some systems that use direct current through the direct current essential bus. You can see here 28 volts, 10 ampere hours. So we have the alternate current. We have 115 volts, 399 hertz from its engine. So if I'm gonna turn off the engines, you're gonna see how it works. So I'm gonna switch a little bit this view. Here is a little bit better view. You can see more of the cockpit. You can see the pedestal here with the engines, the speed brakes, and the flaps levers. And here's the trim of the trimmable horizontal stabilizer that I'm going to be talking about later. Here's the ECAM, the navigation displays, and the primary flight display, and the autopilot flight control unit, as they call it, with the auto thrust and 2 autopilots. So I'm gonna come here in this display, maybe make it a little bit bigger than it is, so you can see the displays here. So here we have it right now. Here is the fuel I was telling you about. It needs a wing tank, the outer wing tank, the inner, and the center tank. And you can see the fuel pumps, the primary and the standby, all working right now. In its wing tank, left or right, inner wing tank, and the high pressure, low pressure fuel valves are on right now, except from the cross bleed. If I'm turn this, the X feed, if I'm turn off the primary, you can see here in the display actually that is changing. You can see it shows the pumps are off right now. Only the standby are working. So I'm gonna turn them back on. we're gonna have an engine failure like that. But I'm gonna turn off the engines anyway. So we have engine number 4 right now. It's off. Now it started again. So I'm gonna turn this switch off for the engines. All switches off, and you see here all the fuel valves are closed from these switches. There's 4 switches. You can see it here in the ECAM display. So we have no fuel in the engines right now. We also have some electrics here reconfigured. So we're gonna have the alternate current. We have no electrics in the engines right now. So the APU is gonna start feeding the system, electric system. So the APU is working well. So I'm gonna need some. The hydraulics are okay. I'm gonna need some from the air system. I'm gonna use the APU bleed here. You can see the APU is on right now. If I turn it off, you can see there is no bleed air right now. If I turn it on, there is bleed air. But I don't need the packs for engine start, so I'm gonna turn the packs off. And then maybe I can use the isolation here in the closed position, because I'm gonna start the left engines first, number 1 and number 2. Here the electric, you can see some reconfigurations. So if I'm gonna turn the batteries off, maybe we're gonna have the APU feeding this system. There is no failure in the electrics. So I'm gonna start the engines now. Maybe I'm gonna come here in this view again. So I'm gonna turn on the engine start selector in the ignition start here. You can see this turns the packs off automatically, and also activates the engine start, if I remember well, the engine starter initiates the engine starting, and, by compressing the engines through the bleed air. So I'm gonna turn engine number 1 on. So you're gonna see this is the engine master switch, which initiates the sequence by letting the fuel go in, the fuel low pressure valve on. So you can see here the engine is starting. We have engine number 1 starting. We're gonna have engine number 2 starting in a while. I'm gonna turn the engine number 2 master switch on. You can see the engine here is spinning the front fan, and here it starts. When N2 reaches 22%, I think, yeah. It lets the high pressure fuel valve goes on. So I'm gonna continue with the number 3 and number 4, but first I'm gonna turn this in the auto position maybe. So I'm gonna turn number 3. Cannot see it very well actually. Maybe you can see the spinner here. Yeah. You can see we have all engines except number 4, which I'm gonna start right now. It's good to have 4 engines. So I'm gonna come back again here. We have everything set up for the engine start. Now I'm gonna turn the switch here. So if I'm gonna turn the ISO on, we're gonna have continuous ignition into the engine. It's already on the engine ADIs. We're gonna turn the packs on, and everything's okay for the takeoff. All the systems. So I'm gonna make a quick start here. You can see I didn't talk to you about that. This is the trimmable horizontal situation indicator trim, which is also trimmed automatically and manually, and is used to balance the aircraft in flights. And also I'm gonna use this position for takeoff 2 degrees up. It's the horizontal elevator is the wings in the tail of the aircraft. It's over here, which also contains the elevators, which I use the side stick to move them up or down. So I'm gonna show you now an inner view, maybe. So I'm gonna set up a flight plan right now, a very fast flight plan. So I should have done this with fuel predictions, maybe fuel close weight, center of gravity. It's actually 390,000 pounds. But it's not allowing me to do that. So I'm gonna just set the flight plan. SZ8 back to SZ8. This is departure and arrival airport from Zurich International back to Zurich International. I'm gonna go align the RS. Clear the discontinuity. I'm gonna need some more. Maybe from this light. So I'm gonna set the coast index and the cruising flight, which is gonna be 35,000 feet, and 250 actually. It's flight level Let's see it. So I'm gonna use a departure here. Runway 14. Transway 12, insert, and then the arrival. It's gonna be the same runway with ILS. Trans Negrio 1 insert, and here we have it. We have the whole flight one created. So I'm gonna use flaps 2. The THS is right. You can see it here with the flight controls. We have 2 degrees up. Here's the flight plan created. Here you can see the modes which are on the vertical navigation and the horizontal navigation. The nav. So I should press this in actually, and yeah, here we have it. So if I press this, it's gonna have this configured in the not heading but managed from the flight management computer setting. So I'm gonna use the performance 2 degrees, flaps 2 and 2 degrees up. I have V1 maybe 145, 150 and 155 V2. So we have them here displayed, the V1, V2 and V rotate with 150 knots. Here is the climb mode and gates, which is the vertical navigation. Here is the horizontal navigation. Here is the engines and the auto thrust, which is armed in blue. So I'm gonna start taking off right now. I'm also can use the ILS here. So here we have it. We're ready for takeoff. We're aligned with the runway using the rudder pedals. You can see we have reached the rotate right now, so we can take off. Retract the landing gear. You can see our airspeed right here in the primary flight display. The lever glide message, so you use the thrust levers, move them down to the glide dead end right now. Here is the alpha prod speed with the yellow tape. I'm gonna be talking to you about later. Here's our ILS, which is used for aligning the aircraft with the runway. This is vertical and horizontal alignment and guidance to the runway. So I use less of this setting to show you some of the airport. You also can see the flight plan over here, which is created, and I'm gonna be following right now. So we have 25 minutes to go until landing this aircraft. I'm gonna bank roll right now. You can see the primary flight display and the navigation display, which is for horizontal awareness, and this is for vertical and horizontal guidance. Here you can see the altitude we're flying right now, 5,600 feet. Here we have radar radio display. We don't have it right now because it's for less than 2,500 feet, if I remember well. Here is the rate of climb, which is 1,700 feet right now per minute. The airspeed 155 knots. Maybe we need a little bit more of airspeed, so I'm gonna use manual airspeed. Maybe 250 knots is okay right now. You can have some other aircraft maybe displayed here by using this beyond position. You can see we're heading to the first waypoint right now. Over here, the Zui, and after that, maybe we can have it here in the flat plan. We have all the waypoints with the altitude altitude and airspeed constraints, as you can see. Here is Germany, this part, all the way up to the right in front of us, and here's Switzerland to the right and back of us. So here we have Germany on this side. Here is Switzerland, as you can see. You can see I'm using the side stick to fly the aircraft, which commands the flight control computer to command allowed shift change for the aircraft, which is independent of airspeed, as they say in the FACOMs, in the flight crew operating manuals. So I'm going to retract the flaps a little bit further to have more margin for airspeed, because my engines right now produce a lot of thrust, 90.8% in the climb mode right now. You can see the modes right now which are engaged in the flight mode annunciator. You can see we're flying at 10,000 feet right now. Let's have an outside view over here. Of the Airbus A340. You can see we're climbing slowly. It's a heavy aircraft, so maybe I'm using more airspeed. from the flight control unit. Here is the airspeed section of the autopilot. So we have 19 more minutes to go for this flight. So I'm gonna make a fast expedite climb right now. So I'm gonna use here the altitude, which I forgot to set to 25,000 feet. It's a bit of slow simulation. Here we have it, 35,300 feet, 330 knots. Heading is managed, altitude is selected, and airspeed is selected, and we have no autopilot. They're both off right now. We can climbing. We are at 70,000 feet right now. Here we have our waypoint. You can have an outside view right now. We have maybe 17 more minutes to go for this flight. I'm gonna start turning back in the airport in a while. We're at 19,000 feet. Our airspeed is Mach 0.52 right now. Or 240 knots, as you can see here. You can see our rate of climb is very high right now. It's 2,900 feet per minute. So we're gonna be in less than 1.5 minutes at 25,000 feet. We're gonna start turning a little bit to be closer to the airport, save some time. 16 more minutes to go. Keep climbing, turning towards the airport. $22,000 feet. Maybe we have some chemtrails right now. Not yet. I don't know why. To keep turning to the airport because we're tight in time. We only have 15 minutes to go. So here we are at 25,000 feet, which are selected and managed altitude. Here is the marking of the airspeed, which is gonna stall the aircraft if we make a bank angle maybe more than 40 degrees right now in this configuration. So I should not try to avoid this slow airspeed or high angle of attack as we fly, because we don't want to stall the aircraft. We have to plug higher, I don't know, to see some chemtrails, but we have to turn back into the airport right now. Have no chemtrails. That's okay. You can see how the fly-by-wire system is holding the aircraft, is trimming automatically if I'm gonna turn up to 33 degrees, there is no need to change, to make corrections. If I exceed the 33 degrees, I can turn up to 67, a maximum bank angle of 67 degrees. So I'm gonna turn very fast for the landing, and we have 30 minutes to go. Use the direct 2. We're 44 nautical miles away from the airport. We're at flight level 250, 35,000 feet right now. So I'm gonna start descending, maybe. Make it faster for the landing. This decreases the thrust over here to the engines, but the thrust lever sets the same in the glide but dependent mode. So I'm gonna also decrease the airspeed, use some speed brakes maybe. You can see how the auto trim manages the airspeed when we descend by holding the thrust levers to the idle. Only have 12 minutes to go to landing, so I have to be very fast without landing. Because this video ends 12 minutes from now. I cannot record more than that. So I'm gonna use 7,000. I'm gonna make some shortcut for landing if I can. To make it faster. 31 nautical miles away. Use not speed brake to go faster. We have 10 more minutes to go, so it's gonna be very fast. Now we're just 26 nautical miles away from the airport. We had some overspeed here, which I cancelled by using the speed brakes. With a little bit more thrust. We have 9 more minutes to go to the airport. We're very close actually to the airport. So I'm gonna use a little bit better view here. Still far away, we're 12 nautical miles away. We only have 8 minutes to go. So I'm gonna have to make a shortcut for the landing. You can see the runway here. You don't have to descend very fast, like flying a fighter jet. On this situation, I only have 7 minutes to go. We're very close to the runway right now. I'm just right in the position I want to be. I want to be a little bit lower. So maybe use the landing gear to slow down. We're in a very good position to land actually. Just a little bit higher. We still have 5-6 minutes to go. So I think we're gonna make it for this landing. We need to get a little bit closer to this runway. I'm gonna start using flaps. Maybe a little bit more first speed. Try to align with the runway. Yeah, we need flaps. We're in a good position right now. So we have only 5 minutes to go for landing. You can see how can I align myself using the ILS localizer on, which tunes the localizer frequency. The ILS is already tuned. You can see the runway here that I'm gonna land. Have to align myself with that and keep the altitude constraints. We only have 5 minutes to go. I believe we can make it. Use maybe flaps full. Use a little bit more of thrust. We have some clouds right now. It's not good for this position. We also need to align. That was very bad cloud. We got our view over there in the runway. You can see I'm having here the localizer and the ILS here in the primary flight display. We just need to descend a little bit more, a little bit higher than we have to. But we are in a very good position to land. So maybe a little bit thrust again. I'm using manual thrust right now. We have 3 more minutes for this video. So we're gonna make it, we're gonna land. $200, 50, 40, 30, 10, 5. And here we have it. We use the brakes and reverse thrust. We use idle and reverse thrust from the engines. Here we landed. You can see our reverse thruster is deployed. You can see the right view and the left view of the engine. Here we all landed at exactly the ILS is tuned and aligned with our heading and frequency right here, and the localizer. You can see the runway we are landed here in the airport, Zurich International. You can see here the thrust reverse is engaged in the engines. The thrust reverse blocker doors are deployed in its engine right here. I can actually close them off. We don't need the thrust reverse right now. So I'm gonna turn this to the idle, have them off, have them on again, turn them off again. You can see how they're deployed. You can see the landing gear here. Everything is safe. We have no tires blown or struts broken. Here is the nose wheel. It's perfectly safe. So we had a very successful landing. I'm gonna be talking you about, I'm gonna show you a view here. Some of the systems. If we had a little bit more time. But that was Thomas. I was the pilot flying the Airbus A340-300 using this side stick. So I was very happy to see you in this flight. I'm gonna see you in another flight next time because we got no more time right there. Okay. I'm gonna show you some more of the systems right now, if I can. We have a little bit more time, I think, but I'm not sure. So I'm gonna disengage the reverse thrust. You can see the thrust levers here. This is how I engage the reverse thrust here by pushing down this lever.